Hello, welcome to the next lecture in the topic programming in C. Today we will be talking about the concept of memory. Right. In the last lecture we went through the basic computer organization, that is, we talked about the different components, hardware components of a computer system like CPU, bus memory, storage, things like that. Now what we'll do is we'll see one of these components, which is memory, in a little bit detail. Okay, so first of all, let me draw a diagram showing how different types of memory or a certain hierarchy of different types of memory and how they interact with the processor. We have the processor, CPU, central processing unit here. Okay, we have what is called as a cache memory. Okay, then we have what is known as the main memory. Okay, then we have what is called as the secondary memory or storage. Okay, so the way CPU interacts or transfers data between these three types of memories is like it is cache is always in direct connection with the CPU. Okay, main memory, it can be in direct connection with the cache, also it is in direct connection with the CPU, right? But when it comes to the secondary memory, it does not connect directly to the CPU, it connects to the main memory, right? So this is how a basic connection between the CPU processor and the different types of memories are taking place. Now let's see these types of these memories one by one. So let's start with the obvious first one, which is the cache memory. Okay, cache memory. So what is cache memory? So cache memory, it is used to temporarily store data which is frequently used. Okay, so the thing is that when it comes to the running of a processor or a computer, many times what happens is that the processor will have to repeat certain instructions and certain data very frequently. So the idea is that we use a very fast memory, okay, cache memory, to store these data temporarily. It's not a permanent. Both cache and main memory are not considered to be permanent storage. Okay, some part of main memories will come to that. Okay, at least for the time being, let's say cache, it is very fast, but it is not a permanent storage. So, and it is used to store very frequently used data. Okay, it can be instructions, or it can be certain values, data values. Okay, so that is the first thing. So two properties of this is, one thing, it is volatile. Okay, then the other thing is it is random access. Okay, and this is also a semiconductor memory. So actually cache memory and main memory are always semiconductor memories. Secondary memory or storage, it traditionally used to be things like your hard disk drive, which is a magnetic storage, or your optical drive, or your floppy disk, which is almost not used now. So all those are certain non-semiconductor, will be magnetic optical type of data storage. Nowadays SSD, solid state drives are coming, which are again semiconductor storage only. It's similar to concept technology similar to what you use in a pen drive is. Okay, pen drive can also be considered as a secondary memory or a permanent storage. Okay, so this volatility is what you say when whether the data is being stored permanently or temporarily. Okay, it is volatile, means it is stored temporarily. Random access means in technologies like magnetic strips and optical discs, or even this magnetic disk, your hard disk drive, data is stored in a sequential fashion, right? It cannot be just stored anywhere. You have to start from one point, the reading head will have to go to some certain point, and it is stored and it is read in a sequential fashion. But when it comes to semiconductor memory, it's not like that. You can store anywhere. This sequential issue is not there. Okay, sequential memory, sequential storage or sequential access is a problem because it introduces a lot of latency, or it slows down the reading process, or reading or writing process. Okay, so cache. The second type is one type of main memory, which is called RAM. The expansion of RAM is random access memory. Random access memory. But don't think that only this is a random access memory. Cache is a random access memory, and the next type of memory that we will be seeing, that is also a random access memory. So this is a primary memory. Okay, random access memory, and this is also volatile. Okay, this is also volatile. So what is it used for? What is it used for? Suppose you are running a certain program, then all or most of its code, a program is basically a set of instructions, right? Instructions and data. Any software is. So when you're running a program or software, what is done is, whatever is required to run that program or software, it is taken from the main secondary memory or storage, and it is put it into the main memory. And out of that, if a certain instructions or data is being used repetitively, very frequently, it is stored in the cache, right? So it is basically the computer manages these three memories depending on the convenience, right? Convenience and use, how frequently and when certain instructions and data are used, right? Again, this is volatile and random access. This is also a semiconductor memory, right? Semiconductor memory. So this is RAM, which is one of the types of primary memory or main memory. So as far as the processor is concerned, the processor will have a certain it will have the ability to address certain amount of main memory, right? It may not be limited by how much secondary memory it can handle, because it is secondary memory is always connecting with main memory, but the limitation of the CPU limits how much main memory it can handle. And cache is usually placed on board the CPU. It comes bundled. Nowadays, if you look at it, most modern processors will say, okay, it has certain level amount of cache, that too L1, L2, different types of caches inbuilt along with the processor, right? So this is usually in the same board or same chip as the CPU, but main memory is different. Okay, so RAM is a type of main memory. The third one is ROM. It is also a type of primary memory, and it is read only memory. Okay, so here the name is sort of correct. The thing is that most of these names were given in the early days of the development of computers, processors and memories. So nowadays the role that these devices take has changed somewhat, but still we stick to that memory, that nomenclature. Okay. So read-only memory is nowadays it's not exactly read-only, but most of it is read-only, in the sense that it is a non-volatile memory. That is, it the whatever data is stored in memory in ROM, it won't be erased as soon as the power is switched off. For cache and RAM, since they are volatile memory, as soon as the power is switched off, whatever data is in there, it will be wiped out. And when you restart the system, or when you give power again, it starts again. Okay. But for ROM, it is not like that. It is a non-volatile memory. That is, whatever is there, it is there. You can change it. It is not exactly read-only. You can change it, and you don't need specific hardware for that. In earlier days, it required specific hardware to do that, but now it is not like that. Okay. So it is non-volatile. So what is the actual purpose of this? It is used to store things like BIOS, right? What is BIOS? Basic input output system. Nowadays, even what type of BIOS is used is changed. Newer systems are being used, but still the basic idea is that whenever you start a computer, you turn this machine on, the processor is there, it's just staying there. It requires some instructions for it to act. Okay, those instructions which are required to start the system, and like I mentioned, if you need to run some software, whether it is a system software like an operating system, it has to be taken from the secondary memory and loaded into the main memory, and some part has to be loaded in the cache memory. So whatever is, these things has to be done initially. Only once the operating system is loaded into the main memory, then it can run and it can start doing things. But that has to be done, that process, it is called booting. So that process is done using ROM. That is the significance of ROM. Okay. Earlier, I think we have slightly discussed about firmware. So that is written here actually. Firmware is what we have in ROM. Okay. That is, it is software only, but it doesn't change very frequently. If you have an update to your BIOS or your whatever booting up system, then you can change. But more or less, it is constant. It doesn't change frequently like the data in the RAM or cache changes. Right. So we have RAM, ROM, that is primary memory. Okay. Then we have the secondary memory or storage. We'll come to that. Okay. So this is a hierarchy. Usually it is drawn as a pyramid. We'll come to that. Okay. That's it. We'll discuss that after we finish storage. So we have what is it? We have storage, secondary memory, or storage. Okay. So what is it? It is a permanent storage. Permanent storage. So, and what kind of technologies are used? Optical, magnetic, and nowadays many machines, new machines are having solid state SSDs, right? Solid state devices. So what is happening? Basically, your cache will be in the range of certain MBs, right? Your RAM and ROM may be in the range of maybe 16 GB of 8 GB around 10 GB, let's say. But that is not enough to run a system, right? For example, even your operating system, whether it is a Linux or a Microsoft, it requires tens of GBs, right? 20 to 30 GB at least it will require to store just the basic operating system. So that is the bare minimum. Then you need to store other software, you need to store other data, whether it is like things like movies, songs, your PDF, and you have to store other softwares, whatever. So that kind of things which are permanently stored are stored in the main secondary memory. Sorry. So that is how it works. Whatever it is there, right? So I'm in this main memory. Let's write it's at RAM and ROM. Okay. So ROM is sort of like a let's redraw this. Okay. We have the CPU. Okay. We have the cache. Okay. We have the main memory. I'm writing RAM. Okay. I'm writing RAM. So okay. Then you have the ROM, which is in a similar category as RAM itself, but I'm drawing it separately to show that there isn't much interaction between secondary storage or secondary memory or storage. Okay, so this is sort of an independent thing. Yes, there can be some interaction between RAM and ROM, but for the time being, let's say it is independent. Okay, so this is how it is. As far as the proximity and speed and the capacity, things like that changes, it's like we have the cache. This is how it is usually depicted in textbooks. Cache, we have a primary memory. What is primary memory? This is primary memory or main memory, primary memory. This is secondary memory. Okay, then we have secondary memory. So how does this change? As you go up, speed and cost increases. Okay, as you go down, storage capacity increases. Okay. Cache is, what is cache? It is a very small memory on board the processor. Okay, it is very close to the processor, and being close to devices, it affects in the considering the frequency in which things are operating. Being close matters physically. Okay, latency matters. It is a small memory and it is very fast. Then there is primary memory, which is consisting of RAM and ROM. Both are having separate purposes. Okay, it is faster compared to the storage, but it is not as fast as the cache. Then there is secondary memory or storage, which is used for bulk storage. Okay. So for example, you can consider this like you're having food. Okay, you have a big let's say big plate of or big dish of food, whatever. You have a small plate from which you are eating, and you are eating, right? You are eating, and you have some food in your hand and you are eating. So you can consider this huge storage as your secondary memory. You can, and from that you transfer it to here, right? You don't directly eat from this plate, this huge dish, and you transfer it to your plate. So you can consider this as your primary memory, and from there you transfer to your hand, then only you are eating. So this you can call as your cache memory. Okay, so I hope you guys are clear with regards to what memory is. So that will be all regarding memory. So we'll see a little bit about softwares and programming languages in the next lecture. We'll just briefly go through certain things regarding software, and after that we'll start with algorithms and flowcharts. Then only we'll move on to the actual C language. Okay, thank you.